Welcome, good day. Welcome again to Peace Online Basic Chemistry. I believe you have listened to the first tutorial on Introduction to Chemistry. That is indeed a part of the introduction. Today we'll be doing a part 2 of the introduction because there are basic concepts you must understand before we go into basic chemistry. And finally, we'll be concluding the introduction with a part 3. But today we're focusing on part 2 of this introduction to chemistry, and we're looking at scientific methods. Here we begin to ask ourselves, what is scientific method? It is an accepted, logical standard pathway which scientists must take during their study of nature in testing their hypotheses developed by series of observation of their surroundings to arrive at theories which can be built upon by further investigation to obtain scientific laws and principles in a bid to understand the world around us better. Thus, we begin to tell ourselves that being a scientist is not just about getting to study a particular course in science. It involves inherent qualities and abilities that helps us investigate our observations in our surroundings and patiently test them to obtain a reliable result. Thus, we begin to ask ourselves, what qualities should a good scientist possess? The very first one is curiosity. A scientist must be able to look at the things around and ask questions. Why is this happening? And then another is patience. A scientist would not be in a hurry to achieve results because he wants to achieve a reliable result. Another is courage and persistence, because so many experiments will want to frustrate you with wrong answers and wrong problems. But they would keep on for years, for time unknown, until result is obtained. And another is creativity. You must be able to think outside the box. You must be able to envision what is not seen to be a scientist. You must be able to bring into existence your, as in creativity, into the physical world to aid man and help the living standards of man. Another on the list is that a scientist must be detailed. He must be detailed to be able to pay attention to the minutest detail of the happenings in your surroundings to get the accurate observations obtained. And also in reporting experimental results, the scientist is detailed in telling the true minutest information of the experiment. Another is communicative. A scientist must have good communication skill because you cannot be an island. A scientist must be a part of a team and also working, even collaborating with other colleagues all around the world, as well as sharing, divulging your information, your experimental data, your experimental results. So you must have the communication skill to be able to achieve this. A scientist must not be biased. He must not have a pre-informed result within while carrying out an experiment. Yes, you have an hypothesis, you have a guess, but at the same time, you are working open-minded because the guess could be proved wrong. And last but not the least, in fact, this is a very important quality, that is critical thinking and problem solving. Do you want to be a scientist? You must be able to analyze information critically and make the decisions necessary to solve experimental problems. Here is a schematic diagram illustrating scientific method. The first here is observation. Yes, a scientist looks around the environment and sees things happening. The curious nature of the scientist raises up a question from the patterns observed, and this question results to a hypothesis. The scientist presents a guess of the possible reason for those happenings. And of course, the next line of action will be to test such guesses if they are right or wrong. And that is done by the means of experiments. During the course of the experiments, further observations are obtained. The scientist is a detailed person and so takes record of all the observation gotten. And then these results and observations that are recorded will inform the next action of the scientist. If positive, further investigation or experiment is carried out on the result to further prove the result. And if the result still comes out positive, then it becomes a scientific theory. With collaboration from other scientists, a scientific theory is further investigated within available limits of evidences. It becomes, if proven true, a scientific law or principle. But you must note that if at any point of this experiment a negative result is obtained, the scientist goes back to the drawing board and reconstructs the hypothesis or makes an entirely new one, and then the process is taken round in circle again. So, in conclusion, the basic parts of a scientific method are the observation, the pattern, the question or the problem, the hypothesis, experiments, and the result. We have come again to the end of this Introduction to Chemistry Part 2. I hope you enjoyed it. You can go over the slides again, listen over again, and get acquainted with these things. They will help you in further study of chemistry. Bye, till we see again for the final part of this introduction. Thank you.